All right. So I'm just going to start from scratch. When you open up Rhino, the first thing you'll see is this window, and there's going to be like 4 different viewports. Sorry, I hope I'm pronouncing that right. It will be available on the YouTube channel very soon. Scott, if you're still here, maybe you can link the YouTube channel in the chat. Yeah, so Scott will send you guys a link, and yeah, it will be recorded.
All right, thank you.
Yep, welcome. All right, so just gonna move this over here. Yeah, so this is what, for you, it may not look exactly like this. For example, you might have 2 columns here. So what I like to do is have the most space available to sort of view my project. So you can like just drag this and make that bin column smaller. You can also move this around. This is your layers. These are your properties. The main sort of default view that you want to be in is like layers, and maybe in a view like this. You can, of course, double click any of these viewports to bring them up. And I'm assuming you guys haven't really used Rhino yet, so I'm giving you like a really quick, like really basic intro. Is this all new to you? Like, have you already like covered how to use like viewports and how to open up Rhino, stuff like that? How to draw curves and lines?
Yeah, we used Rhino for Arc 100 assignment.
Oh, okay, awesome. So then you already know all of this. I'll just give you guys some pro tips then. So say we have like an object here, right? So that's an object, and you rotate obviously by using your right mouse button, but sometimes it gets like lost and it's rotating around some other axis. So normally when you press the middle mouse, you'll get a different. So if I go to my document properties, I'm just going to show you what happens by default. I think it's this one. Yeah, so by default, it shows you this little icon, and there's a lot of options here you can click. But for me, like what I like to do is if you go into document properties and select this option, run this macro, put in ZS so that when you press the middle mouse, it'll just zoom to that selected object. And that makes rotating around things much easier. So if you have another one over there, whoops, so you can like zoom to this one, rotate around this one, or you can zoom to that one really quickly. So that's just something I like to have set up. I'm assuming you guys know how to use O-snaps here, pretty basic. So we'll just hop into Grasshopper then for your first assignment. Today we're going to be creating this script. It's a mess right now, but I'll clean it up. Didn't really have that much time to make it, but what we'll be creating is this wall, which contains, maybe it'll be easier to see if I turn everything off and just enable this one. So it contains some divisions, and you can change the number of divisions using a slider. And we'll get this wall that is parametric and contains sections, and I think that's what your assignment is asking for. So we'll start with the sort of this assignment handout. Part 1 is to create a parametric wall. And okay, yeah, so there's a few ways. So we'll just get started right here in the below here. The way I created this wall is using a few different points. So these 1, 2, 3, 4 different points. And then from those points, I basically got this curve. And I got another curve. So by just moving that. And then what I did was I lofted them to create the wall. So that gives you a surface. And from there, we use this little block here. So I'm just going to group this and keep it separate here. And what this is this is just for dividing up the surface. So these sliders control how many divisions there are. From there, so that's basically your part one of your assignment, right? So it's asking for a Nurbs, so curves or points, and we're using sliders to control our wall. Part two is from these inputs, we're going to generate a surface, which we have done with Loft. Okay, so we're then going to discretize the surface into smaller elements. So divide that. So minimum of 25 discrete components. So you can basically multiply them. Right now we have like 60 different components. So if we wanted 25, we can sort of make it make this number much smaller. So yeah, so this will give us like 30, which is pretty good. So this meets the requirements. And from there, we're going to, yeah, we can add some characteristic property that is controlled using Grasshopper. For example, percentage perforation, curvature of panel, offset of shading fin. So what we've done is this one here. We've created a so if I skip to the end, we can call it a shading fin or some sort of fin. Yeah, it could be anything. And I'll just show you this, but you can like really make it anything. It could be like a hole in the wall. Yeah, so it's up to you to decide. Yeah, have I lost anybody so far already? Okay, I'm gonna think that's a no. All right, so we'll go on to the third part of this assignment, just breaking down what it is asking for. So with this script, we're going to create a wall that is, we're going to create 4 different walls just by changing the sliders. One that's long and straight, one that's short and high, one that is sort of S-shaped like you've seen here, and then one that is long and varies in height on the top side between 1 meter and 4 meters. Okay, so we'll do all of those using our sliders. And number 4, 3 different designs. You must vary at least one characteristic property across the surface, creating a gradient condition. So that, I'm not sure if you've noticed, but you can sort of see in the top view that some of these shading fins are higher than others. And that's the sort of the gradient condition that we're talking about here. Cool. So let's get started with our script. The first thing we're going to do is inside Rhino, we're going to create 4 different points. So I'm just going to start with 1 point, and I'm just going to hold Alt and copy these around. Oops. So there's 4 points here now, and we'll reference them. So in Grasshopper, I'm guessing this is your first time using Grasshopper, right? Correct me if I'm wrong, please. Okay, awesome. So Grasshopper, to bring it up, you just type in Grasshopper in the command bar, and this is not the normal screen you'll see. You'll see an empty screen, and it'll have like on the bottom some of your recent files which you can open. A good sort of what I do is I just have this screen sort of smaller and on this side, on the right side, so I can sort of see if I want to just my perspective and see what I'm working with. And sort of to explain, one more thing is like by default, this is not how your Grasshopper window might look like. So if you go into view, there's a few options here, and the ones I've enabled is, first of all, canvas toolbar. So if I turn that off, this toolbar disappears. So we want to have that because it'll help us sort of show and hide things. I'll come back to that. There's also the components tab, which is how you can visually select components. You can, of course, like everything you see here, each one of these is like a component. So this block is called a component. And you can also search for them. So what I just created was trim with brep. I can also just double click anywhere. That'll bring up this search bar. I can just type in trim. And there's a few different trims. I think the one I brought up was trim with brep, not breps. It was this one. Yeah, so you can also sort of see that's where, you know, it came from. And there's also a lot of components that we're going to be using today. You can all see like where they sort of come from. I'll also like type them in and you'll know the names. So that's the components tabs, panel separators. So that is sort of, you kind of see that. I actually don't know what that is. I'm figuring it out. Okay, so it just sort of adds a little separation between, yeah, it's just a personal preference thing. Maybe, you know, you can have more things here. So, okay, we're gonna turn that off. Ribbon tab icons. It's best to keep it on ribbon tab name. So it's best to turn this off so you can see which plugin you're using. So everything here is a plugin. So Kangaroo by default is installed with Grasshopper. So you're going to see this. You're not going to see Speckle. You're not going to see V-Ray unless you have that installed. You're not going to see Horster or Firefly. These are plugins I've installed manually. We can cover that in the end if we have time. But yeah, so going back to sort of the display, if you go into the next tab here, which is display, there's a few helpful things to have here. So by default, I think you're going to have draw icons instead of the name. I like to turn this off so I can see sort of the partial name. That helps me sort of when I'm like reading other people's scripts or, you know, yeah, it'll show you what this is and you can sort of figure out what that says. So this is interpolate. So if I type in int CRV, I get interpolate. So, and that's what this is. So this gives us the name and it is easier to type in. If you're like more of a visual person and you find things this way, you can use icons and sort of search for them here. But we're going to keep this on. We're going to keep this off so we get the names. Draw fancy wires. That's just a visual thing. And draw full names. So that you might also want to turn on because it helps you sort of figure out what the inputs are asking for. You can always highlight, like hover over them and see sort of what's coming in and what they're asking for. So curved, like right under the name, there's a short description. These ones are really short, just as curved degree, but some of them are a bit longer, like this. If I can get that back. Yeah, so it says like not spacing, and then it tells you what the values will do. So 0 is uniform, 1 is chord, etc. Okay, one more thing under display is to go into canvas widgets and turn all of these on. Compass is like down here. You don't really need it. It just tells you where your code is. So if you're ever lost, you can see like that compass pointing to your code. Awesome. So that's basically it for this tab up here. This is where you get your components. And so this bar, we've enabled it from, I think it was Canvas Toolbar. This is really important because you can sort of, so this, if I go back to my drawing, so I'm just going to enable everything again. Where did it go? Look at that. So right now, like by default, you'll see everything. And sometimes you want to just, you know, not see the Grasshopper stuff. So you just click this little icon here and it won't draw anything. You can also click this to sort of wireframe everything. So you can still see, like, for example, this point here, it's hard to see now, but now I can clearly see it. There's also this icon here, this green one, and that will let you basically only render what you click on. So if I click on this, I also have to have this set to the shaded geometry first. So this just means that everything I'm seeing in Rhino and in Grasshopper will be visible in Rhino. And then I can use this when I have this green one selected, I can click on each one of these components and it will draw only that component. So it's easy to it's more clear to see. If I turn that off, it'll draw everything. We can also like select components and like if you middle click on your mouse, you have this ring icon, and you can sort of turn everything off. You can turn on select things. So that's this enable preview icon. You can also do this by like if I wanted to hide this again, right clicking and then setting the, right clicking on something. So I guess I can't do it in a group. No, I can. Okay. So right clicking and then turning the preview off. Okay. So this right click method only works on sort of individual blocks. So you can turn off preview for individual blocks or do the same. Yeah. So that's basically an intro into the UI of Grasshopper and getting like searching for components. So you can search for like curve, whatnot. And wires. So you already know that you just connect components to the main essence of Grasshopper is to connect like components together and have data pass between them and by just dragging and dropping. If you wanted to sort of, yeah, you know what? The rest of it I'll come back to as we do this block of code here. Yeah, any questions so far about the UI? Okay. All right, let's keep going. So we started off with drawing these 4 points in Rhino, and now we need to bring them into Grasshopper. So there's a few there's like these main like components, these blocks that sort of act as a reference. So they reference certain Rhino geometry. So there's point, curve, rep, surface. There's more as well, but these are the main ones that you sort of need to use. So for example, in this situation, if we want to bring in these points, which one of these do you think we'll need to use? Type it in the chat. Let's make this more interactive. Exactly, point. So let's delete that and let's double click and search for the point component. Yeah, and that's it right there. So when you see this icon, just click it. And now that will give us the ability to bring these in. And how we do that, we just right click on this and select. So there's these 2 options here, select 1 point or set multiple point. So since we have more than one, we're not going to be using this one. We're going to be using this. And now the order in which you select them is important. So that's the order that the points will come into Grasshopper as. And order is everything in Grasshopper. Like how things are ordered is very important. So we'll go left to right. So click this, and Grasshopper sort of creates this line just to help you see the order. The line disappears afterwards. But now when you click on the point, you'll see a green highlight. And you can hide all of your Rhino stuff now. So if I just select that, hide that, that way I don't accidentally bump it and move it around. So now I have my points. What I want to do is have a way to use sliders and move them along the y-axis. So left to right, if I'm looking at it this way. And I'm going to do that by first searching for the move component. So obviously I want to move points, so that's what I want. And the move component wants 2 things. It wants a geometry and it wants the motion or a vector in the direction you want to move it. So we take our points and we put that into geometry. And by default, it sort of has something in here. So that's why it sort of moves it already. But that's not the direction we want to move it. We want to move it in the Y direction, right? If you can see this little axis here, Y direction is where we want to move it to get it to sort of curve. So then we're going to search up unit Y. So these are unit vectors. And Y is the one we're going to need. We're going to connect it to motion. And now the factor is going to be how much do we want to move in that direction. By default, it's set to 1, so which is why everything moved 1 unit to the right. But we're going to create a slider. And sliders are a different type of component, which allow you to enter inputs like values. And the way you create that, you can obviously search for a slider and click, this is the one, number slider. And you can double click on the number slider to change its properties. So you can set it min, max, a range. You can also set the number of decimal points. So right now it's on real and there's on 3 decimal points. If I drag this sliderception, right? Then I can have, and I hit OK, I can have 4 different decimal points. And if I click on n integer numbers, then I will only have like solid numbers. Right now it's just between 0 and 1. If I wanted to make it between 0 and 10, I go double click on my min. That's set to 0 already, awesome. Then I double click on my max and I set that to 10. Hit OK, and now this slider goes from 1 to 10, 0 to 10. But there's like a quicker way of creating sliders, and it's, you might want to write this down. You start with the minimum value and you type that in. So let's say we want a slider that goes from negative 10 meters to 10 meters. Okay, so we're going to type in negative 10, that's a number. Then we're going to use this less than sign, and that automatically turns it into a slider. And we're going to put in the default value, and you can just put in whatever value you want it to be like by default. I'm just going to set 0. Then I'm going to do point. If I want it to be just integers, I wouldn't add a decimal point. But since I want there to be some decimal points like in the control I have, I'm going to add how many decimal points I want. So I'm just going to add, like, if I had just 1 0 here, I'd have 1 decimal point of control. If I had 2, I would have 2 decimal points of control. So like just finer control. I'm going to set this to like 2 decimal points. I think that's enough. Then I'm going to add another less than sign, and this is going to be my maximum range. So since I said I wanted a slider between negative 10 and 10, this value will be my maximum, 10. Once I hit OK, so you'll see that this number slider has 2 decimal points and it goes from negative 10 to 10. Awesome. So we're going to connect it to this. And now if we move this slider, we'll see that when do you use amplitude in the direction? Oh, amplitude. So we'll come back to amplitude actually. We use that in our code right here, amplitude. So this is useful when you already have a vector, when you have a direction that you want it to go to, but you want to change how much it goes in. Since we're only moving it left, and we don't really have like a finer direction, we can use a unit Y, but we'll come back to amplitude and when we use it. Okay, so yeah, so this is a slider, but now everything is moving together. And that's because if we look at the value of this, if you hover over this, it says there's one locally defined value, and it's applying that one value. So if we hover over this, there's 4 values, which are our 4 points coming into geometry, but there's only one thing coming into motion. So, you know, it's taking like this one thing and just like repeating it a bunch of times, and just that's why everything moves together. If we wanted individual control, we need to give it 4 different values from here. And there's a bunch of ways you can do this, but what I can do is copy this number slider, and you can do that by just Control-C, Control-V, or by holding Alt. If you just first click on the thing and then hold Alt and drag it, and you can create copies. Excuse me. Yeah, if you hold Alt before clicking anything, then you can actually like add space and stuff. You probably won't need to use this. It's just nice to know. You can just keep growing your script in case you needed to sort of add some space to add another component in here if there wasn't any room. Anyways, we have these sliders now, and we can then connect each one of these to the factor here, and that would create a list of values. But if you were to just click this and drag it into the factor, it's going to disconnect the other one. And the same thing with this one. If you just click this, drag it into this one, it's going to disconnect everything that came before it. So what you need to do is hold Shift, and you'll see a little plus icon. It's really, okay, I didn't want to do that. It's really tiny. You might not be able to see it in my screen, but there's a plus icon, and you just hold that, and that will allow you to create, connect multiple outputs into one input. And if you now hover over this, you'll see this as 4 different locally defined values. And I'll introduce you now to another very useful component, and that's called a panel. You can search for it. It's right here, panel. There's also a shortcut for this. You just do // and that gives you a panel. And that lets you sort of see the output. So if we hover over this, we can kind of see the same thing, but this gives you more detail and ability to scroll when there's lots of data. Yeah, plus icon. So you should see it when you hover over an input, like a wire basically, and you hold shift. It also turns, I guess the arrow turns green as well. And that lets you connect multiple things to one. Okay, I hope that answers your question. Yeah, so this panel lets us see that there are 4 different values in here, but they're all the same. But if I change these now, you can already see it sort of change there, but these values change. And they change in the order that we put them in. Okay, so again, order is very important. There's like a bunch of points here now, so I'm just gonna right click, like middle mouse button on this and hide these points, my original points, so that I only see my moved points. Next, I want to type in, so I'm going to create a curve, but there's lots of different ways to create a curve. If I just type in curve, you'll see there's like Nurbs Curve. There's like, okay, there's more curves, I promise. Yeah, there's like Interpolate, which is actually an Interpolate curve. There's also like, what was it? Polyline curve. Yeah, polyline curve. There's a difference. So I'm going to show you like Interpolate, and I'm going to show you Nurbs. They're all sort of Nurbs curves, by the way. Like if the question asks to create Nurbs curves, you can pick any one of these. So we're going to take these points, which came out of our move, and then we're going to connect it to vertices. This gives us a polyline, which is just going straight lines, point to point. There's also Interpolate, which will give us which will give us this like curved line that goes through each one of these. So the green one is the one I'm like highlighting, by the way. And then there's also Nurbs Curve, which is like it uses, so it has a start and an end, and it also has a degree. Right now the degree is 3, so that means it's like super smooth. If I set the degree, so with a panel, I can also use a number slider. You know what? Maybe a number slider would be easier. So I want to create a number slider, right? So 0 is my minimum. I want it to be only integers, so I don't add any decimals. And then my maximum, let's say like 5, just to show. Realistically, 3 is the maximum you want to be for degree, but I digress. So if I have just 1 degree, it's basically a line. You can see it's the same as a polyline. So it just goes from point to point. If I set this to 2, then it's like a little bit of a, like basically this controls the amount of attraction each point has to the curve. So the lower the number, the more attraction it has. So if I had 3, it's a little bit like less closer. 4 doesn't really change actually. So it's just 2 and 3 that really change anything. But what you need to know is like either set it to 3 or 1. I don't think you'd ever need to set it to 2. It does something, but I forget. So let's just go with Interpolate, because this gives us a very predictable curve because it goes through all of our points. So once we have our Interpolate, what we need to do is, yeah, we're going to create another one, but first we're going to move each one of these points. Okay, so we have our curve. This could be our wall, and we can just extrude it up right away. But this won't really give us an interesting, like the thing we have here. So if I show you this, I have additional sliders here that let me control the height at each point of my wall, okay? So you can kind of see that here. And to create that effect, what I did was, again, I need to move these points. So I'm going to create another move component. And the direction I'm going to move them in is the Z direction. So I'm going to use unit Z. And what I need to do now is, so what am I moving? I'm moving these points. So I'm going to take this, connect it to geometry. And which direction am I moving it in? I'm moving it in the Z direction. So I'm going to take this, first connect it to that. But now I need to give it some, like, again, sliders. And I can, again, I can just copy these sliders over. It'll be easier. But again, if I want to copy it, create new sliders, I can just do do it like this. So if I wanted to go from like, I don't know, like 2 meters, a difference of, let's say, yeah, so like the lowest height I'd want it to be is 0 meters, obviously. I don't want it to go below the ground. Number of control decimal points, let's say 2 decimal points. And the highest I want this wall to be, let's say 10 meters. Okay, so it's going to create 4 different ones and connect them each up in order. And that gives us, well, we can now adjust the each one of them individually. Oh yeah, so meter, good question. That's a very, very good question. So the units in here will be the same as the units in your Rhino file. So right now my units are in millimeters actually. So if I change this to meters, hit OK. Do I want to scale everything? I'm going to say no. So now if I type show again, everything here now will be in meters. So if I like look at the distance between these, so that's the distance command, and so that's like 8 meters between each one. So it's a big wall right now, but it makes sense if I'm going like 8 meters this way. It's about the same distance, if you can see. Yeah, so my units are going to be whatever your Rhino units are. Okay, so let's move on. I'm gonna hide all of my points again. So I have this now, another set of points, and I can copy this again, interpolate, and connect it to my geometry to get another curve. Now I have 2 curves, and you can kind of see them if you select them both together. I'm gonna type in loft to loft between these 2 curves. So it's gonna hold shift, and that gives us a wall surface. How are we on time? Wow, we are so behind time. Oh, okay. So that gives us the wall. Now what we need to do is divide this wall up, and we can do that with a group of components. So the first one I'm going to type in is called divide domain squared. So if I type in divide domain, I'm going to select this one, not the one that just says divide domain, but the one that has a little squared icon. Next, I need ISO trim. So ISO trim, and it's this one here. Next, I need some, actually 2 sliders. So, and this will determine how many divisions I have. So I'm going to say 0 to 30 divisions each. So I'm going to copy this. And how I'm going to connect them together is, well, this is looking for a domain, which is just basically our loft. So we're going to connect that there. How many U and V is how many divisions I want. I'm going to connect these sliders, and I can change the sliders, and that gives us segments. And to actually see the segments, so right now, if I highlight over this or just add a panel, you'll see it has some output, which means it's working. So I'm going to connect this loft, my surface, to the surface component of this ISO trim, and the segments will go into the domain. And if I click on this now, you kind of will be able to see like a grid appear. And it's like sort of weird when it's like over here, it gets really packed. So maybe this really curved wall is not a good idea. So I'm going to adjust that to be slightly more reasonable. That makes sense. Okay. Again, this is like meters. So this is how high the point is from the ground. So once we have our ISO trim, what we need to do is extract more information from it. So we're going to do deep-rep. And that will, when we connect the surface to there, it'll give us like, it'll give us points, and like these faces will be individual. All right, so next up, what we need to do is, okay, so that was that. Yeah, so next up, we're gonna sort of evaluate, so get a point, get a set point in the middle, absolute middle of each one of these sections. Because if you look, if I use a list item, so list item, let me check in that again, is a useful component that we'll again touch upon later, but it takes a list. So everything here, when you connect it to that, so this is a list, okay? this is also a list. So whenever you see like 0, 1, 2, 3, that means it's a list of values, right? So if we take the faces and connect it to the list, and we'll create a slider. So it's an arbitrary value that I'm going up to, let's say 100. If I connect it to index, also I need to do something. It's good. Yeah, so once you deconstruct rep, sometimes the structure of the list is going to be like this. Whenever you see like these divisions, that's not good for list item. List item was not going to be happy with that because it's only going to see one item in that list. So what I can do is right click on the output here, and that gives us these options. So there's reverse, I can reverse the list, I can flatten it. That's what I want. Graph, flatten, and reverse, and maybe reparameterize are the ones that you're going to be sort of using. I'll explain each one I use them. Firstly, flatten, what that would do is take that weird looking list and make it into a simpler list. Just, yeah, so it just has like values, it's simpler. And list item like understands that better. So if I have both of these selected, or maybe if I turn that off, you can kind of see that I can select, I can address each one of these panels individually. So I can do something with each one of these panels, right? So what we need to do is, again, get a point in the center, because we're going to create, that's the center of the spike, basically, if that makes sense. And to do that, I'm going to bring in this component called evaluate surface. It's this one here. It's like a little ball with a point. So evaluate surface is what I want. And the surface I want to evaluate will be each one of these faces. So I'm going to connect that. And the point I need is going to be from another component. I'm going to call this, so this is called MD slider. And it looks like this. You can sort of make it a little bit smaller. We want to make sure it's at 0.5 colon 0.5. And what that would do is, as soon as we connect that here, oh, and we also need to right click on this surface and reparameterize it. And what that would do is treat the whole surface as a between 0 and 1. So it would say that this point here is 0, 0, 0. So if we look at a 2D, a Cartesian grid, this point here will be 0, 0, and this point here will be 1, 1, and everything in between can be addressed by decimal values in between 0 and 1. This is useful because if you have like this wall, right, and you don't know the size of it, and you want to point like 2 meters this way, or like you want to point in the center. How do you know how far the center is, right? If you don't know the size of the wall. So that's why if you reparameterize it, right click, reparameterize, this would this would basically give you an easier way to address the whole surface, right? So it creates a bunch of these planes, right? So I'm just going to hide this because it's super ugly. But what I want from here is that point. So I'm going to, again, use the point component just to bring it out. I could drag it simply out, but it's just cleaner this way. So I have this point component. Now I can like see that I have a point in the center of each one of these faces from my deep rep. And again, just to sort of go back a few steps, deep rep came from isotrim. Isotrim came from this sort of group. So I'm going to group this again, Control G. If you select components, you can right click. So first select them, and you can Control G to group them, and you can kind of group them for infinity. I just learned today. Wow, that's super awesome to learn. Okay, cool. So once you have some grouped, you can move them around together, and it helps to keep your code organized. So for example, this group I just made here, the loft isn't part of it, but these two things are always sort of, they come hand in hand. Well, okay, that's not the right phrase, but they come together basically whenever you're trying to do a division. So I can group them. I can right click this and add a little name. So I can say divide surface, right? There's also cool things you can do with groups. If you right click on the group, you can select the type of group it is. So there's like blob group, there's like rectangle outline. This is like really cool. Yeah, so you can select, you can make it look nice. I just go with box outline. So once we have our point, we also have, if I go back a few steps to my deep rep, right, which was here. So this is my deep rep. If I create another point and I connect the vertices to it, you'll see that I have like a point at each vertice of the face. So those points are what I'm going to be using to create my pointy shading fin. But before I do that, I need to actually like take this point and move it off the surface, if that makes sense, right? Because I want the spike to be like off the surface, right? You don't want it to be like a flat spike because it's just a flat surface. But here, so what I need is move. Like obviously I want to move, right? So that's like I'm sort of thinking like, what do I need? What components do I need in order to get where I want to be? So I have the points. I know I need to move them, so I'm going to connect the points to there right away. But the thing is, what I need to know is which direction do I move them? And it's not just unit Z, right? Like unit Y anymore, like we had before. If this wall was perfectly straight, okay, so if I had this wall, right? Excuse me, and it's just like perfectly straight. So that's a straight wall. I could use like over here, unit Y. So we're gonna connect there, and we'll have like a slider, random slider between 10 and 10. So I can have this like slider here, right? And I can move it around and it looks like it's working. But as soon as you change the curvature of your wall, right, to make it more interesting, so like make it an S shape, so that's an S shape, you'll see that like especially it's better seen on the top view, like these areas, maybe if I add more curvature to the S, it becomes clear. So this is moving up this way, this way, this way, this way, but like over here, it's sort of like, not how you want it. It's not moving off the surface, it's just moving in a line. That's not what you want. So instead, what we're going to be using is actually given to us already. So the normal, remember how we evaluated a surface? So when we evaluate a surface, it gives us a few different like points of information. So it gives us the point that we sort of evaluate at. It also gives us the normal. Move in Y. So not sure what you're asking, but we don't move in Y. We're going to move in another direction, and I'll show you that really quickly. But we don't want to move in the Y direction because, what if you're this is like another case, let's do another example. So you have these points. What if you rotated your points this way, right? Now your like wall is perfectly like flat. Okay, that's not a good example. But yeah, it's because like if part of your wall was like super straight, your points would go in the Y direction, but over here, it's not going to be off the surface. It's just going to be like smeared along the surface. Does that make sense? That's if you put it in the Y direction, but we're going to do like in a better way. So we're going to use normal, which is given to us by our evaluate surface. That's a vector. So if I connect this right away, it does move off the surface properly, but we don't have any control over, how much we move it by. So that's where amplitude comes in. So we're going to type in amplitude. So I don't even need to type it all the way. It just comes in right here. The vector is the direction. So we're going to take the normal, put that in there. And the result, we can just put that into motion. Nothing changed because we didn't, by default, the amplitude is 1. But here we can have a slider, and the slider will go from 0 to, let's say, 2 decimal points. And how far away from the wall do we want the spike to be? Anybody have any suggestions? How spiky do we want this spike to be? The maximum spikiness. 4 meters. All right, sure. That's a really spiky spike. 4 meters. Okay, so we have 4 meters, and we're going to connect that to amplitude. So right now it's at 0, so you see nothing happening. There like all in the same plane. But as soon as we start changing that value, you can kind of see that they move off the surface. And the positive direction for this wall is actually towards us, so this way. Yeah, so you can see that it moves like how we want it. It moves off the surface, perpendicular to the point, so along the normal. That's what a normal is, by the way, perpendicular vector on a surface. So that's cool. We have this, but they're all like changing. You know what, before we get to that part, let's actually start building our spike. And this part is somewhat of a, there are better ways to do this, but they take time. And you know what, this method takes time too, but it's a lot of trial and error for me, especially if there's only like few points. I'd rather do trial and error than make it. Okay, should we do it the easy way, or should I do it the more convenient and easy to do but longer way to make that spike? Let's take a, okay, I'm not going to do a poll, but just you know, just easy way or hard way. Which one do you guys want to learn? I got one easy. All right, nobody else? You know, the hard way is kind of easy and convenient. It's just, you know what, I'll show you guys the hard way. It's not really hard, but what I need to do, there's a few steps. So first I will take one of these points. So I'm going to take a list item and connect it to, so these are my vertices. I'm going to take, actually first, yeah, okay, this is, might be a little hard. Okay, so I'm going to take it, I was thinking, you know what, instead of, yeah, so I'll take one of these faces, connect it to my surface, because a face is right now is a surface, right? So that's why this worked. I'm going to take this, connect it to my list item, and then I'm going to create a panel with the number 1, and this is just going to take, actually not number 1, I'm going to make this 0. So this is going to take the first item in that, which is all the way over here in this corner. Awesome. Then I'm going to debrep it, so that way I get the vertices again, but just for this one point. And then what I'm going to do is use something called, oh, someone just left straight up. Okay, hopefully that was something else. We're going to call in a different component called point list. Now what this will do is if we connect our vertices, which are points, to this point list, we'll see that this gives us like, oh, it's super small, but I can set a value using a panel. Well, it's too big. Yeah, that's a bit easier to see. So it gives you numbers. So 0 is like the first one. And from there, we go to 1 and 2 and 3. So 0, 1, 2, 3, right? That's the order we have. And that will help us, you know, make the spike. So to create the spike, we need a few things. So we need the point here, obviously, right? And we also need the points from our vertices back here from our debrep. So these points. So I'm going to move these points a little bit further ahead. And just to make it easier for myself, I'm going to create another point, connect it to this point. You know what? No, I'm going to take this out of this group. So if I just select this, right click and choose ungroup, I can take that out. Just, yeah, I don't think I needed a group there. But so now I have these 2 points. Actually, sorry. We don't want this point. This point is the one before we moved it. We want a point from here after we moved it. So the point on our surface, which are here, and the point from the spike, which is here. So that's what we want. And what we need is this component called 4-point surface. So type in 4-point surface and you'll get this. It just says 4-point surface. And if you are a visual learner, that's where it's located. Cool. So what we need to do is sort of create surfaces with the corners in order. So we have our geometry here, and if we look at the panel, it's got like a whole bunch of points. Okay, that's actually, yeah. Yeah, I meant to connect it to this point. So this is our 4 points, right? And we'll see that it has like different groups, and there's like 4 different points in each one of these sort of clusters or groups. And these are your 4 different points. So we'll connect that to a list item. And if you zoom in, you'll see these little plus icons. So you have to zoom in a lot, and you can click on them to add more inputs or outputs in this case, but sometimes you can also add inputs in certain blocks. But we need 4 of them because there are 4 points, right? So 0 is this one, 1 is going to be this point here, 2 is going to be this one, and 3 is there. So to create like our first surface, so we're essentially creating the spike like each surface at a time. So we'll create one of our surfaces, which is going to be from 0 to 3, so the bottom one. So I'm going to connect to 0, then I'm going to connect 3, then I'm going to connect our spike. So let's see. And if we, oh, that did not work. Okay, what we need to do is actually technical difficulties. Yeah, that looks super cool, but this is not a good sign. Let's figure out what's going on here. Why did I flatten this? There we go. Sorry. So what the issue was that this geometry was grafted or flattened. What I needed to do was right click on it and select graft. And I won't really get into it right now, but if you ever see something happening like this, like there's like a bunch of different, just craziness. All right. Whenever you see like craziness like this, it's usually the cause because of something that needs to be either grafted or flattened. So, you can just check for, what you think needs to be grafted. So if I just grafted that, and that looks better. Okay, so hope that's didn't scare anybody. So we have one of our surfaces. We need to copy or create another 4-point surface and continue, continue this step of, adding surfaces. So the next surface I'm going to create is going to be the right side of the spike. So that's 0, that's 1, and then our point. So that's good. We'll copy this. The next one, we're going to create the left side. So that's 2, 3, and then spike. So 2, 3, and spike. Okay, wait, that's not right. 2, 3, and spike. So which ones did I take? I took 1 instead. Oops, 2, 2, 3, and spike. There we go. Copy that over. And I'm going to do the top one here, which is going to be 1. I know you guys can't see the 2, but there is a 2 here. That's a 3. So that's 1, 2, and spike. So 1, 2, and spike was already selected. I'm just going to add it again. Once we have all of our surfaces, we can type in join rep. And this will basically join all the surfaces into one shape. And again, I'm going to hold shift for this one. I can hide all of this. So selecting it all, middle click, and click on the blindfold. And that gives us this wall. How are we on time? Okay, we're at 8 o'clock. I think we're going to be done in like 15 minutes or so. Yeah, technically these are an hour and a half, but I try to finish in an hour, but we're going to be on. Yeah, so that's great and all. Like we have all these spikes that we can sort of control using, how many we want by increasing or decreasing this slider. We can also change the shape of our wall. We can make it really short if we wanted to. So another way it's parametric is like, the curve, the points we just created, like we used to create this we can move these around, and that also gives us another level of control over our wall, basically. But we also have sliders here. Oh, I'm getting too close. So we also have sliders here that we created. Again, these were for the Y direction, so left, right. And that these were for the height direction. So up here, we can like adjust that. So that's all nice, but in your assignment, it asks for your for there to be these components that have a gradient like change. So yeah, you know, like the offset and stuff, just changing throughout your shape. And the way you do that, yeah, I'll show you one way to do it. You can figure out your own way as well. But we're going to use a point on the surface that we can move around. And wherever that point is, the closer, like every other spike that's close to it will be really like really high. And the further the spike is from that point, we'll make it so that it's really like flat. Okay. So that step is actually sort of in between the last one of these steps. So the specific area that we need to change is like the height of the spike. So remember, we have a slider here. I think this is the one that changes the height of the spike, right? And it's changing it for every one of them. But we want it to be sort of variable. So we need to substitute this slider with something else. And the something else we need is a few steps. So first, let's find a point on this surface, right? So we have this surface, like this big surface. Maybe if I show you this, it'll be easier to see, imagine. So we have this surface here, right? And we want to get like basically a point on this surface. How do you think we would go about doing that? 2 to 3 of you dedicated students here. I'm sure you guys have an idea. Like just type it in the chat, or just, you know, like you can unmute as well. What component do you think we'll need? I'll give you a hint. Yes, surface commands, definitely one of those surface commands. I'll give you a hint. It's in this screen here, okay? It's one of these. Yes, exactly. Good job. So it's evaluate surface. We use this to get a point in the center of our little panel, but this time we're going to use evaluate surface to get a point on our loft. So this is the loft is the surface we're going to be connecting, and we're going to connect a MD slider. So MD slider just means multi-dimensional slider. It's basically a number slider, but in 2D. We're going to connect it there, but first we need to reparameterize our surface. Okay, so I'm going to move that closer to this slider that we need to replace. So we have this, great. I'm going to turn that back on. This gives us a point. It's sort of hard to see, but you'll see this frame. I just pointed to my screen. I don't know why I did that. This frame is moving through your surface. You can get it to be anywhere, right? And next, what we're going to do is to basically, we want to get the distance between this point and every spike. So we'll type in distance because that's the block we want. Point A will be basically this point here. And point B, now we have, again, we need to get a point basically at every single point, like every single facet, right? And we had this point here, right? Remember, like we had this point here, which is basically in the center of every single one of these spikes. So we're going to drag that over, and that gives us a bunch of different values. We can use a panel to connect that and see what sort of numbers it gives us. So it's like, yeah, like decimal points, you know, cool. But we're not quite done. So we have this point, we have these distances. If we were to just plug this in into our amplitude, we could do that at this point. I'll sort of show you what happens. Yeah, some weirdness happens. So you can move this around, and you can kind of see that everywhere wherever the point is. So right now the point is like over here. Like all the other spikes are super like long. As soon as I move the spike over to the other side, these spikes get super long, right? So it's working, but we don't have a way to control it. And in order to control it, we could use, it's similar to the concept of amplitude, but amplitude only works on vectors. What we have here are still like decimal, like floating point, like numbers, basically. They're still numbers. And to sort of remap them, we use the component called Remap Numbers. And so the thing we're going to remap are basically the distances. So we're going to connect that. Now, the source and target, these are your domains. So, you know, like what are the lower and higher limits of the values? It's easy to get it's easy to get the bounds or the limits for distance. We just type in bounds and connect the numbers. So it takes basically, how it works is it takes the highest number, which is like 15 or something, or 20 maybe, and it takes the lowest number, which is probably like 0, and it gives you basically, yeah, so 1.9 to like 24. That's what it says. That's all it does. And that goes to source. And our target is actually going to be created by us. So we're going to give it the target bounds. And we can do that by typing in construct domain. Not the construct domain squared one, just singular linear construct domain. And we can connect the domain to the target. And domain start and domain end will be, again, controlled by 2 sliders. And this will control what the lowest amount of spikiness is and what the highest amount of spikiness is. So let's say we want the lowest amount of spikiness to be 0. So that's fine. We're going to add 2 points of decimal, 2 decimal points of accuracy. And the highest spikiness, like we sort of said, was going to be 4 meters. So we're going to set 4 here. I'm going to duplicate this and connect them together. And now I can just take the mapped value and connect that to amplitude instead. And by default, what you'll see is that nothing happens because our sliders are 0 right now. But as soon as we sort of increase that, we can control what the maximum spikiness is and what the minimum is. So right now it's between 0 and 4. So the furthest point will be 0, basically flat. But if I were to like increase the furthest point, so I can do that as well. And maybe it's easier to see if it was more spikier. So I'm just going to change the maximum range to 20. It's going to be crazy. Yeah, so you can kind of see this more exaggerated. If I were to bring these both to like 7, just going to duplicate this. So if these values are the same, all the spikes are the same. If this value is less than this value, then wherever the point is, so this point that we are moving around, so you can see it here, moving this point around, wherever it is, so right now it's here, it's going to be really low. And the further away the spike is, it's going to be like this number. We can reverse that logic just by changing the slider. So it's spikier where the point is and less spiky where there is no point. And I think that's it. Yeah, just gonna move this here. Now I will go over the script again. I'll explain very quickly what each one of these, what they do. If you have any questions at any point, feel free to sort of unmute or just message. Yeah, so we started with this point here. This set of points, actually, there's 4 points that are referenced, and it's these 4 points. Then we move them. We move them in 2 directions, actually. So if I go into my perspective view, we move them like sort of left, like sideways, and we also move them up. And that gave us these 2 curves. The curve in the bottom is flat, but the curve on the top is has the ability to be changed up and down. Then we lofted them. So that's what the loft does. It creates a surface. We took this loft, we separated them into like sections, and we have control over how many sections there are. From there, we deconstructed the BREP, which is the boundary representation surface object, and we took these faces, which are each one of these individual like surfaces, and we evaluated them. This is quite a lot, but what we really needed from there is just the points. So if I hold both of them together, you can see that there's a point in the center. From there, I created, we created spikes, right? So we moved these points, and the direction we move them in is in the normal direction, right? So that's where they came from. The amplitude, we'll get to that. We're coming to that point. So we move them. So these are the points. These are the points that we moved. They sort of look like that. And we used our, we used a list item on the points that were on the surface. So these points are from the DBREP. So it's 1, 2, 3, 4 points in a set. They come in sets. So there's like 0, 1, 2, 3. Like these are your indices. They're numbered. So each face is numbered. And within each face, there's also like 4 different points that are numbered. So it's sort of like a list within a list situation. So we've flattened them just to make it easier. Yeah, actually, we didn't need to flatten this actually. So if I didn't flatten this, we didn't have to graph this. We wouldn't have to graph this. So it's all nice. The only reason we flatten this is sort of to get that preview, but I realize now that I should have flattened this. So I can flatten that, not the output of this, so that my little code here. So what this does, we can group this and move this aside because this is optional. This just gives us an idea of which points are which in our edge here. And we use that information to basically get this list item. We separated each one of these points out, and we used the 4-point surface. So like you can kind of see what they each do. They're like parts of the shape. And if you wanted to, this might be interesting. You can, opt to remove one of these surfaces and just, do something like that. So it's up to you sort of how you want the spike to look. But I'll bring it back and we have this BREP closed. But the real interesting part of it is like this section here. This is the point remapping and like distance control. So we first got a point that moves along the surface, right? That's the surface. You can kind of see the shadow of it. And we got a point, and then we got the distance between that point and every other point, right? So these 2 points. And then using that distance, we remapped it according to our sliders. Yeah, and then we just put that into the amplitude. So the amount to move it by, and that sort of translated forwards throughout our script and created this. So that was it. If you have any questions, this is an excellent opportunity to ask. What you get that the people that are watching on YouTube don't get is the ability to ask questions. So please feel free to do so. Or not, if you understand all of it. You can always message on message AALD on Discord or Instagram. And yeah, that's pretty much it. In that case, bye everyone. Thanks for tuning in.